let us continue on our previous example on the hydraulic series number 4 about horizontal drain size. I have lived before about example on the horizontal drain. Okay. This is the example that I have given to you. I copied it also from the textbook or the book itself. Many copied this kind of example. But how is their solution? And how is the solution for the proper plumbing engineering course? Okay? Okay. Let's say for example, we have there one area of zone, one zone which has a level of A, B, C, and D. It has its own vent system and it has its own stock system or soil stock. And then discharges to the stock system or the soil stock of this zone were connected of A, F, G, S, and I. We are interested on these red lines because these are the label that we will have. A, B, C, D, E, F, G, H, I. We are interested in that. Okay. As we know that A is 70 fixtures unit, B is 90, C is 120, D is 90. So as we discharge it to the soil stock, the total of this level A, B, C, and D is equals to 370 drain fixtures unit. As it discharges, they call it offset. Meron tayong offset. No? Okay. How many intervals that we will have? E, B, C, and D, there are 4 intervals. Do we have to know how many intervals that we will have in the design of a drain system or the design of a plumbing system? Yes, we have. It is needful that we have to know how many intervals that we will have. Why? Because these intervals, if it is too much and you cannot size this soil stock, it will overload the soil stock itself. Pag nag-overload na ang soil stock, ano mangyayari? Okay, we will go later. Okay. So, it discharges to the offset, to key. Okay, this is, we have a horizontal branch as the offset of the total fixtures unit for level A, level B, level C, and level D. This is equals to 370 drain fixtures unit. We have to solve what is the size of this offset stock. Is it the same as the soil stock or a little bigger than the soil stock? Okay. It drains to another stock. The second stock that we will have is stock L, letter L, where level A discharges, letter F, level F discharges, level G discharges, and letter H discharges, and letter I, level I discharges to the stock. And the total drain fixtures unit are here in the letter M. What is the size of this drain pipe? Okay. In half full flow for using, let us say we are using a CI pipe. You can use PVC, yes, why not? But for an example, we are using CI pipe. Our computation from the horizontal drain, the diameter is 0.74, Q is the power 0.375. That is from the slope of 1/4 inch hole per foot. The results is in cubic feet per second and diameter is in feet. So this is the English system. Okay. In 1/4 inch hole per foot, from this table 806, from the plumbing manual of US Bureau of Material Standard 66, the equivalent values of the fixtures unit here are this. Okay. You have a 1/4, 1.5, 2, 3, 3. This one here is being, the fixtures unit is being displayed because maybe our truck size is in 1 1/4, 1.5, or 2 inches. That is our drain pipe. Okay. The 4 inches, if we follow this 1/4 inch per foot, is 216 fixtures unit. We will solve based on this that we have a 1/4 inch hole per foot, that we do not overload the capacity of a pipe diameter as we assign pipe diameter. So this is 216. We have to pig for 216 fixtures unit if it is 1/4. For 6 inches, we have 790. For 8 inches, we have 1,920. So, this shaded yellow area, we are focusing on this to determine the diameter, that we do not overload also the pipe itself. Okay. So, these are from the US Plumbing Manual, Bureau of Material Standard 66. Now, on the multi-story, the drain fixtures unit for soil stocks or waste stocks are this. Okay. The 4 inches, I line it red lines, and 8 inches, 6 inches, I line it red also. Maybe we select it from 6 or to 8, whatever it is. Okay. The number of branch intervals. The A is the maximum of the horizontal drain that's discharged to the soil stock. The B here represents the maximum fixtures unit allowed for discharge into that stock. That is the stock, the soil stock. Okay. If you have 4 intervals, branch intervals, these are the values for 4 inches. This is 90 and 360. This one represents here, this one represents the fixtures unit of the soil stock, and this one represents the fixtures unit of the horizontal branch. It says here that the column headed A is equal to the maximum load within any one branch interval column. Within any one. It says only one. Pwede na isa. Okay. The column headed by B is the maximum load on stock. So, our 4 inches, say for example, at 3 branch interval, a letter A is 100 fixtures unit. That is the horizontal branch, the maximum for one branch, and B is the maximum for the stock itself. Why? Because 3 times 100 equals to 300. That is the fixtures unit of the stock. Okay, let us go back to this. You have a different fixtures unit on the horizontal branch. The biggest fixtures unit is 120. we have the branch intervals of 1, 2, 3, 4. We have the branch interval of 1, 2, 3, 4. So 4 branch interval. If we follow on the table what the table had said, okay. Our branch interval, if it is 4, the maximum of the fixtures unit here is 90 for the horizontal branch. And the size of the pipe for the stack is 360 fixtures unit. So that is for four branches. Huh? Because 90 times 4 is equals to 60. You see, 100 times 3 equals to 300. 84 times 5 is equals to 420. So this equivalent, branch interval 3, 4, 5, 6, 7, 8, 9, 7, 8, 10, 12, 15. These are the intervals, the branch intervals. And what is that branch intervals? The minimum of 8 feet. The minimum of 8 feet that is in between. It means to say, the minimum of 8 feet here is the branch interval. You can raise a little on the branch interval for 10 feet. But when you go down to 6 feet, that is not anymore a branch interval. The branch interval is the interval between branches. That is the distance between the level. Okay. I said, why do we need to identify branch intervals? Identifying the branch intervals on drainage stacks is critical to protect against, number 1, overloading. Number 2, increased venting problems associated to what? To turbulent flow from branch discharges. So, a turbulent flow from branch discharges will create a disturbance and might create the problem on stacks itself, in the soil stacks. Okay. So the branch interval here for this table A8 is 90 and 360. That we have to resolve that problem for 90 because in our design, in our problem, in the problem that we have, 90, okay, pasok ito, ang letter B, level B, ang level D, pasok. Shall we consider 120 fixtures unit? So, yan ang kailangan natin i-resolve. We have to solve if it is by consideration that this fixtures unit, we solve it through an engineering equation. Okay? Okay. So I said, kailangan we have to identify how many branches because some other laws or some other code, it says only below 3 branches or above 3 branches, but they do not specify how many branches. I said, that is not correct. So this one is from the Bureau of Material Standard.